In my other video, I showed you how you can use SGL with local models like Llama, Mistral, Gemma. In this video, I'm going to show you how you can use SGL with API-based models such as OpenAI. If you don't know what SGL is quite a nifty project which allows you to control your LLM's output in a structured way. SGL stands for SGLang. It's a structured generation language designed for large language models. It makes your interaction with LLMs faster and more controllable by co-designing the front-end language and the runtime systems. It allows you to have a flexible front-end language that enables you for easy programming of LLM applications with multiple chained generation calls, and we will also see shortly when we install it and use it in our code. It also allows you to have advanced prompting techniques, control flow, multiple modalities such as text and images. We will deal with both. And also it enables you to fork it in a parallel way. You can also have a high performant runtime with radix attention that primarily accelerates execution of complex LLMs programs by automatic KV cache reissues across multiple calls. It supports techniques like continuous batching and tensor parallelism. So that's it. Let me take you to my local system and then we will start installing it and we will play around with it. And of course, I will drop the link to this GitHub repo in video's description. I will be installing it on my Ubuntu system where I'm running Ubuntu 22.04 and I have one GPU card of around 50 GB of VRAM. As you can see on the screen, it is RTX A6000 from NVIDIA, and both the VM and the GPU are sponsored by Massed Compute. So really hats off to them. Thank you for giving this awesome VM. If you're looking to rent the GPU, please check them out. Amazing rates and prices, of course. Let me clear the screen. Another thing I would highly suggest you to have is Conda installed. I already have it. If you don't know how to install it, please search the channel. You should be able to find few videos around it. So I already have the Conda. Let me clear the screen. I'm going to create a virtual environment with SGL in Python 3.11. Let's wait for it to create the virtual environment. Simply press Y here and press enter and it is going to install SGL locally. The environment let's activate this environment and you can see that it is now activated in the parenthesis. Let me clear the screen. That is done. And now let's install our SGLang. I'm just going to do pip install SGLang and it is going to install everything for us locally. So let's wait for it to finish. Shouldn't take too long. SGLang is installed. In the next step, go to platform.openai.com and grab your API key from OpenAI. That's a paid option, of course. If you don't have the account there, sign up and you might get, I think, $10 credit, which should be enough for running this demo and plenty of other things. But if you already have the account, just put in $10 there if you don't have it already, and you should be able to get the working API key. So let me set my OpenAI API key here and then I will clear the screen. That is done. Let me fire up my Python interpreter and then we will be running this SGLang. First up, let's import some of the libraries which include some of the decorator functions from Python and also OpenAI's library. That is done. Let's define some of the functions which are going to do the bulk of the heavy lifting, and I will also tell you what exactly these functions are doing. So first up, I have defined this function multi-turn question, and on top of it, I have decorated it with the function which we imported from SGLang. This question, this multi-turn question is just taking two questions and then concatenating them in a system user assistant fashion. So system is a whole AI system, and then user is us, who are asking the question, then assistant is the model. Let's set the default back into GPT 3.5 Turbo. You can also set it to GPT 4, but as GPT 3.5 is cheaper, so that is we are using. Let's run our state, which is just asking you two questions. So what is the capital of US, and list the local attractions. And now let me print out the messages, and this message actually will show you the magic of this SGL. There you go. You see, so first system, user assistant. So we are controlling the output of the model. So if your application needs the output in a specific way, confined way, you can do that with the help of SGL. That is the whole purpose around it. For example, if you just want the answer, you don't want anything else. For the first answer, just type this, and you see that you got your answer back in an easy, fine way. That is done. Let me clear the screen, and then we will see another example. In this example, we will see how to do the function calling or tool use. So let's import the SGLang again, and then let me define a tool use function. Let me put it here. Okay, so I would just need to fix the indentation of it, or maybe what I'm going to do, I'm going to put it in a Python file that will make it easier to call it. So you see, I'm just creating a tool.py file in Python. I have just given it an execution right, and then let's open it. And I'm going to paste the whole code here, and I will describe it, and then we will run it to make things easier. So I have pasted the whole code here. Now let me show you what exactly this code is doing, and then we will run it. First up, we're importing the SGLang, then we are defining this tool function, which it is just going with two tools. First is calculator, and the other one is search engine. If you don't know what exactly these tools are or functions are in terms of or context of LLM, in a simple language, whenever you want to interact with your external applications or APIs through LLMs, you use tools, or some people also call them functions. So here we are using a calculator tool, or we are searching the internet with a search engine. So that is what tool is. And then in the next function, we are just taking the suggestions. Fork means that it will be run in parallel, which will speed it up. And then we are just checking the regular expression. This is another feature of SGL, that it supports the regex or regular expressions. And then another one is that where we are testing the question answer. This is where the tool function is being called. This is where the tip function is being called. This is where the regex is being called. And then we are testing the batching. Batching means where you group multiple questions together and then ask it. Framing it where it just streams it in a chat way. And then this is our main function where we are calling all the functions which we have defined above. And for the default backend, we are using GPT 3.5 Turbo. So let me save this file, and then we will run it from our Python. So I have saved the file. You see that I am running it. Okay, so let it finish first. I'll just scroll above. There you go. So you see, so I just started this tool.py. The first one, to answer this question, because we were asking it what is the capital of US. The capital of US is this, and then we were asking it staying tips for staying healthy. It has given us a tip, and then we were just asking it few other things. Okay, so it says that regular expression is not supported in the OpenAI backend. Okay, that is fine. We are not using it because you can use it the llamas or other open source models, so that is fine. And then there you go. It has given us the DNS public IP records of Google's. That is fine. And then it has just downloaded some stuff from here. And this is our batching function. You see London, Paris, and Tokyo, and then the singular one. So how good is that? So the crux of the matter here is that we have managed to control the output of the LLM however we wanted, whether it was streaming, whether it was single question answer, multiple question answer, batching, with the help of this SGL library. So all this SGL is doing at the back end, it seems, it has defined some of the decorators, controlling the prompts, and then giving us the result back. How good is that? Let me clear the screen now. Another cool thing about SGL is that it also supports multimodality, which means that not only text, but it can also deal with the images. So let me show you the code which we will be running. So this is a file I have created. So again, we are importing a library, then we are just decorating this image function where we will be asking a question from the image. The image path contains the image which I already have uploaded to my system, and I will also show you that image. And then I'm just defining a function single which takes that image, and then the prompt goes to the model and then return us the response of the model. And this is where we are defining the model, which is GPT-4, and that's about it. And we are just printing it out here. So if you want to use a local model with the image, you would need to use Lava, not any other. So that you can do, and you can check it out in my other video. So let me get out of this file, and then we are going to run it. Before I run it, and this is how I'm going to run it, I just want to show you the image first. So let me take you to my browser, and this is the image. So it's just a sunset with some of the kangaroos, birds flying, tree on the left, and that sort of stuff. So let's go back and run this and see what it does here. And if you remember, the prompt was only what exactly that image is. That's all the prompt was. There you go. So you see, it is saying this is an image of a painting depicting a sunset or sunrise seen with a large glowing sun in the background and silhouettes of what appear to be kangaroos in the foreground. That is true. There is also a silhouette of a tree on the left and birds flying in the sky. You see, how good is that? So if I just simply go to that file again, this is what we asked. What is this? And it has just described that, and you can confine the output as much as you like. So this is the beauty of this SGL, is that it allows you to control and confine the output of LLMs, and it makes it faster. And if you use forking, which means that you can just fork multiple API calls or LLM calls, it just makes it faster. So that's it, guys. Now you know how to use this SGL, the structured generation language, not only with OpenAI models, but also you can use it with local models like Llama, Gemma, Mixtral. Plus, if you want to use Gemini, you can simply replace that OpenAI's API call through Gemini, and they have these examples on their GitHub repo, which I will drop the link in video's description. So that's it. I hope that you enjoyed it. If you did, please consider subscribing to the channel, and if you're already subscribed, then please do me a favor and share it among your network, as it helps a lot. Thanks for watching.